Okay, now we are going to see another topic in code converter, which is BCD to XS3. So, what is XS3? XS3 is nothing but value plus 3, that is XS3. Okay, so 4-bit BCD. So, what is the maximum possibility? So, here input itself BCD. So, what is the maximum possibility of BCD? So, BCD can be represented using max started from 0 0 0 0, and then maximum we can go up to 0 0 1. So that means 0 to 9. Okay, so this is my BCD value. So then what is excess 3? Okay, so excess 3, as I told you, input value plus 3, that is excess 3. Okay, so here what is, suppose if the input is 0 0 0. Okay, input is 0 0 0, assume this is BCD value. Excess 3 is what I told, plus 3. 3 is represented using binary of 0 0 1 and 1, right? So what is addition? 1 1 1 0 0. So this is my excess 3 representation. So input is 0 0 0. Okay, this is my input, which is BCD. Okay, my output should be represented using excess 3. So for 0 0 0, excess 3 is 0 0 1 1. This is excess 3. Understood? Simple. So XS3 code is nothing but input value plus 3, that is XS3 value. Okay, so every time you have to add input value with XS3, that means 3 should be added. Okay, so that is one kind of code. Okay, so this is the logic behind BCD to XS3. So here BCD is starting from 0 0 0 and 1 0 0 1, but 4-bit has a possibility of up to 15. But what happens to this inputs, that we will see one by one. Okay, so first, for example, 0 0 0 means XS3 will be, how can we represent 0 0 0 in XS3? As I told you, we have to add 3 with that. Okay, 1 1. Okay, so 0 0 1 means 0 1 0 0, right? 0 1 0 0 1 0, which is 2, which can be represented as 0 1 0 1, right? 2 plus 3 5. Okay, so likewise we have to do it. So what happens to 7? Okay, up to 6 we can see. So 6 is nothing but 6 can be written as 6 plus 3, we will be getting 9, which is 1 0 0 1. What about 7? 7 plus 3 is 10, right? So here you can represent 10, because this is XS3 code. XS3 code can have how many numbers also, but BCD is only our input, so we cannot consider BCD input beyond 9, but XS3 can be considered beyond 9 also. So in that case, this will be 1 0 1 0. It goes on. But for 9 plus 3, what we will be getting? 9 plus 3 is what? 12, which is 1 1 0 0. That's all. Our input ends here. Okay. Our input is up to, we can able to give 1 0 0 1, because that is BCD. What happens to remaining inputs? What will happen if I give remaining inputs? So remaining inputs will be considered as a don't care condition. All these remaining inputs will be considered as a don't care condition. So this is how we will write the truth table for BCD to XS3. So my final truth table will looks like this. Okay, my final truth table will looks like this. So I'm representing uh, all the outputs, that means x3 x2 and x1, x3 x2 and x1 x0 in min-term representation. So here you can see I can able to have min-term expression. For suppose if x3, if I take na 5 6 7 8 9, these are all min-term representation. Beyond that, all the things are represented as a don't care condition. So this don't care condition will come for all the outputs. Okay, we can see all the outputs are having don't care condition. So using this, we are going to draw the K map. So when I considered x3, I'm starting from x3. Okay, when I considered x3, this is my K map table. So how many groups will be there? So this is how my groups comes into picture. Okay, I will be having three groups. I'm utilizing don't care conditions also for forming the group. So I will be having three groups. So my expression looks like this. Okay, so next for x2 I will be having three groups. Okay, I will be having three groups. I'm considering like this. Okay, so the expression will looks like this. Okay, next for x1. So how many groups is possible here? Here you will can able to have two groups. Okay, so this one and this one, these two are the two groups. My expression looks like this. Okay, so next x naught, I can have here also. Here I can have how many groups? I can have only one group. We can see that these two combinedly we can have one group. That's why x naught value is b naught bar. Exactly, we are getting. Okay, so when I so for this expression we can able to write the, we can able to draw the uh, logic circuit. So, first thing what we have to know about code converter was what is the logic behind, or what is the logic implemented in the code converter. Okay, so that is very very important. So what type of converter, what is the input and what is the output, and what is the logic implemented? After finding that logic, you have to draw the truth table. From the truth table, you have to start writing the minterms for your convenient purpose. Actually you have to go for K map. Okay, so for going for K map, we have to, if we write a minterm format, it will be easier one. So then we have to go for K map implementation to find the expression for each and every output. Okay, so after finding each and every output expression, we can able to draw the logic circuit. Okay, so this is the BC 4-bit BCD to XS3 code converter. Okay, so I will be giving you uh, practice. Try to make BCD to gray code converter by yourself and try to draw the logic circuit for that. Okay, so that's all about code converters. I hope you understood everything. If you have any doubts, please contact me or post it. Okay, thank you.